So let's go on to sort of our grand finale here. A word problem that's a little complex, and we need to draw an illustration in order to help us simplify it and understand how to proceed to solve it. Let's go ahead and let's do this. So we're given that line AB is perpendicular to line CD and that they intersect at X. Let's go ahead, let's draw a line AB, a straight edge. So we've got line AB. We put on points A and point B. And then it's perpendicular to CD. Let me take my protractor. Let me try to do a real accurate perpendicular line here by making sure that my baseline is lined up. And then picking the point right under 90 degrees right over there. And let me create a perpendicular line. Oops. Okay, so what didn't I do? I didn't put in my origin point. And then make sure I've got my origin point in so that I know exactly where I'm drawing from. And by the way, that's why the origin point has a little opening. You can kind of draw in your origin point if you didn't have one already. And now let's go ahead and connect these two dots. And we've given ourselves line CD. Okay, so we can call this point C, and we can call this point D. So now we have line AB perpendicular to line CD. Well, they intersect at X. We should draw an X. Point X. Over there. The intersection. Now, and since these two lines are perpendicular, we should also draw in all those little right angle symbols, right? And in each quadrant, they have a right angle. Perpendicular lines, when they meet, they form right angles in all the angles, all four angles in all four quadrants. Okay, so far so good. We also know that the measure of each of these right angles is going to be 90 degrees. So let's move on. Line XF bisects angle CXB. So where is angle CXB? Point C, point X, point B. So angle CXB is in this upper right quadrant. Okay, and XF has to bisect this angle. Well, we know that angle CXB is 90 degrees. So knowing what we already know, why don't we go ahead and make an accurate depiction of the angle bisector, which would be at about 45 degrees. So that ought to be, on a protractor, around 45, should be right about there. Make ourselves a point just about there, and let's draw these points, join these points in a line. Actually, in this case, okay. And XF, we'll call this F, bisects angle CXB. Well, that means that this angle, FXC, is equal to this angle, BXF. We can have our little equality notation. Now we also know that if you bisect a 90-degree angle, each of the resulting angles is going to be 45 degrees. Let's go ahead and write in 45 and 45. Okay, so far so good. Let's move on. G is in the interior of angle BXD. Okay, angle BXD, where is that? Well, this is B, this is D, and this is X. So angle BXD is in this quadrant, the lower right quadrant. And G is somewhere in the interior of this. Well, we don't exactly know where in the interior, so let's just pick some point like that, G, and put it in the interior. Now we are told next that if the measure of angle BXG is equal to 32 degrees, find the measure of angle DXG. So let's look for angle BXG. Where is angle BXG? Well, this is B, G, and X. We didn't really draw an angle, right? They didn't tell us to draw an angle, but obviously they want us to have an angle there. So we've got to take our straight edge And we've got to create that angle by joining x and g together and creating a line or a ray, xg. So now, angle BXG is BXG. It's this angle here. That is the angle we're talking about, and they're telling us this angle is 32 degrees. So let's write in 32 degrees for that angle. Now, we need to find the following angles. These are our question marks. DXG. DXG. We need to know this angle. Okay. We need to also know angle AXF. That would be AXF. That is this angle we need to know. Okay, this whole angle, AXF. And finally, we need to know angle AXG. AXG, which is this whole angle. Okay, so we've got those three angles to figure out, and again, we're faced with a situation where we've got a lot of angles that we don't know just yet, but perhaps we can start, rather than starting by trying to figure out the answers to these three bigger angles, start to fill in some of what we know about the smaller angles. So let's take a look. We know that the angle, and I guess it's going to be best, let me number all of the small angles so we've got something to refer to. In fact, let's call this small angle 1, and let's call this small angle 2, this small angle 3, and 4. So 1 is from here to here, 2 is from here to here, 3 is from here to here, 4 is from here to here, and then, well, we know this is 90. We know it's pretty clear up here what these two small angles are, right? This is 45 and this is 45. So we've got an angle 1, an angle 2, an angle 3, and an angle 4. We've got to try to figure out what each of those are, and then somehow add them together to figure out what the larger angles are. Well, let's start. Let's try to figure out angle 2, because in this case, angle 2 is equal to the first angle we're trying to find. Well, you can see pretty easily that angle 1 and angle 2 are complementary angles. Okay, they both add up to 90 degrees. So that means that angle 1, the measure of angle 1, plus the measure of angle 2 is equal to 90. We know that the measure of angle 1 is 32 degrees, plus the measure of angle 2 is equal to 90. And we can subtract 32 from both sides, and that gives us that the measure of angle 2 is going to be equal to 58. But angle 2 is the first angle we're trying to find, DXG. That's the same as angle 2. So we've got our first answer. The measure of angle DXG is equal to 58 degrees. One angle down, two angles left. Okay. Well, let's try to figure out other small angles that fall between some of these big angles. Okay, so let's write in what we just discovered, that angle 2 is 58 degrees. Maybe we're going to need that somewhere. Now let's try to figure out if we can determine what angle 3 or angle 4 is. If we can figure those two out, we'll add these three together to get our second angle. Well, it's pretty fortunate that angle 3 is a vertical angle to angle CXF across from it, which means that angle 3 has got to be equal to 45 degrees. And angle 4, if we look at its vertical angle across the vertex, we'll find that angle 4 is equal to 45 degrees as well. So angle 3 is vertical to a 45 degree angle, and angle 4 is vertical to a 45 degree angle, and therefore we now know that each of these measures is 45 degrees. So there's a large angle which is AXG, measure of angle AXG, is going to be equal to the sum of 45 plus 45 plus 58. So measure of angle AXG is equal to 45 plus 45 plus 58. And when you sum those up, you get 90 plus 58, which is 148 degrees. So we've got our second answer here. The measure of angle AXG is equal to 148 degrees. And our final angle that we need to figure out is the measure of angle AXF. AXF. Well, that actually is pretty easy, right? You could have done that one without too much trouble even at the beginning. As it turns out that AXF is equal to this right angle, AXC, plus the 45-degree angle, FXC. So 45 plus 90 degrees. Let me do it over here. 45 plus 90 degrees is equal to 135 degrees. And therefore the measure of angle AXF is 135 degrees. So that completes this problem. And please, if this isn't entirely clear to you at first, feel free to watch this video a couple of times. And after you've watched the video, you should take the diagram, draw it again, and see if on your own you could reconstruct all of these measures so that you can do this pretty easily on your own.